Hey guys, welcome back to the shop. In the previous video, we've got our new Vise spindle here that we set up, and we did our cross hole. We drilled it and bored it on size, and I showed you this piece of material, which is going to be our vise handle, and we've got a nice precision fit on that hole right there. Really nice fit. I just love that. So anyway, what we're going to do today is get this guy turned in thread. A little bit of manual lathe work is what we're going to work on. And this is a piece, I believe it was 440C material. Got it from McMaster-Carr. It's the Thompson brand, Thompson hardened shafting, but it's 17-4 stainless that's been case hardened and then ground. So you have a nice hard surface on that that's going to kind of reduce any kind of wear, scratches into the surface there, but provide that nice polished surface like stainless steel will. And it's nice and strong there too as well, so you can definitely use this as a vise handle. But what we're going to do is replicate the original vise handle here, just like this. So this is the one that comes in the hardtail vise, and the way they have it made is this end I think is formed with the ball on it, and then this end is turned and threaded, where you have a threaded rod and a threaded ball there. It screws together so that you can stick it into the spindle and put it together. You can use them Loctite on there so that the ball doesn't come loose, which is what we'll probably do at the end. Just put a little thread locker on there to kind of keep them together. All right, so that is what we're going to do. Now, I had mentioned this before too. These the 6 grooves, these are put in there purposely as a failure point on the vise handle. So if someone is using this and they're really pulling super hard on this handle, or they put a cheater pipe on there to try to get some extra leverage, what it's going to end up doing is bending at one of these grooves here. And that's by design. That's how Jason at Fireball designed this, is that this is an indication that you just over torque the vise, and to stop doing that, and then you can just replace your handle at that point. So I'm not putting these grooves in there because I'm not going to be over torquing my vise. I'm just going to use it. But I said before, I'm kind of building just something fun for the shop. This is a little bit more of a centerpiece, a showpiece. It's a conversation piece. And I've had a lot of fun over the past year or so making all these individual parts for the vise. And it gives me an opportunity to kind of show off different machining operations that we're doing, whether it's going to be on a manual lathe, a CNC lathe, a manual mill, or a CNC mill. We've kind of been mixing it up, and a lot of the machines in the shop have had a part of this project, including the home shop where we use the shaper, we've used the K&T mill, and I can't remember if we've used the other lathes, but a lot of machines have had their hands on this project here. But for today's video, we're going to take this over to our Precision Matthews lathe, and we'll go ahead and get the ends turned and thread. So I've decided I'm going to be using half 13, I'm sorry, not half 13, we're going to use half 20 fine thread. This thread right here, I believe, is 15 millimeter. Let's see what they've got it. Yeah, so they've machined a 15 millimeter thread on that. I'm going to be going with a 1/2 inch, like I just said, a half 20, and that's what we'll use for mine. I've got these ball bearings right here. Now, these are not hardened ball bearings. These are just stainless steel balls that I bought from McMaster-Carr. And these are, let's go back to our inch dimension there. These are inch and a quarter. All right. And my plan is to replicate the end balls that screw on there to look just like this guy right here. So all they've done is they've milled it flat, it's been drilled, and it's been threaded. So we're going to do the same thing with this, but I'm going to be using the CNC mill to do this job right here. We're going to machine some soft jaws for this, and then we'll set up in the soft jaws, mill it, drill it, and we're going to use a thread mill to thread mill the inside, to cut the threads on the inside of that. This will be another video coming up because I'm actually still waiting for the thread mills. Actually, I think they're supposed to be here either today or tomorrow, but we're going to follow up and finish off that as a separate CNC video. So anyway, that's the plan of attack. We'll go ahead and go to our Precision Matthews. I do have some no-go gauges here that we can use for our threading. We have a 1/2 20 no-go and a 1/2 20 go, so we can use those for our threads. So we'll go ahead and get that done, and maybe even get this spindle put back together and get it back in the vise whenever we're through with our threading. We're going to use our Precision Matthews lathe today, the TL1660. And it should be pretty simple. Just doing some turning and threading on both ends. And our thread length is going to be, I think I decided to go with just a 1/2 inch length. So we'll get this turned. It's going to be a little tough, but because there's going to be a case hardened area on the south side here. It's kind of tough, but we should be able to get underneath that and get into some of the softer material. But we should be fine with just turning it a 1/2 inch back. We'll turn it, cut a thread relief there, a groove, and then we'll thread it. So let's see. I think that's probably a decent amount there. I think we'll just go with that right there. All right, let's see how the face is going to react. Well, it'll be helpful if we put it in actual gear. There we go. And get my feed set up. That looks pretty good. Just clean it up here. I'm going to go ahead and set our DRO to a negative 1/2 inch value. All right, let's try our face cut. There you can see the difference between the case hardened area. Might have to get in there with another camera and show you, but you can see with that face cut where the case hardened is and where the softer material is underneath it. There you go. You can see it better with this camera. The hardened outside shell and the softer material in the center there. All right, let's go ahead and see if we can get the outside turned. Now it's possible this might mess up an insert. That's okay, I'm prepared for that. There's also ways that you can soften this before trying to machine it, but I don't want to do that. We just want to try to cut it with our carbide, get underneath it, and see if we can manage that. Go ahead and take a little bit more of a cut there. Okay. Try not to dwell on there. And I got to find my pliers so I can pull that chip out of the way. And I'll tell you what, pull it out this way. Backside. Okay. I will get you guys some nice tight close-up shots so you can see what's going on. Just wanted to get moving on this since we got 2 ends to turn. So we took 100 thousandths off that. I just want to see about where we are. Yep, 646 thousandths. So we got about another 146 to come off of it. This is a 50 thousandths cut. It's been a while since I have turned into this kind of material, and what I'm showing you is that even though it's hardened, you can still manage to cut this stuff if you don't overdo it. You know, slow your speeds down. So I'm actually running 380 RPM on this, and that's just to help not burn up that carbide insert. Yep, so we've got about 96 thousandths to come off. I think we're safe. I'm going to go ahead and kick up the speed now that we're just about out of that hardened section. So we're going to put it in high gear, gear number 1. That's going to be 620 RPM. And let's take another 50 thou. Yep, so now we're finally underneath the softness there. So it's about a 1/16 thick. That's looking pretty good. So you can see it is manageable. It's not that bad. As long as you got you some good carbide to get underneath there, you can turn it down. So we're just going to turn this down to 0.495. In fact, I'm going to go ahead and kick it up 1 gear. Let's go up to 900. And I got to measure it again because I didn't pay attention to what my reading was there. All right, 46 thousandths. So about 50 thou. So what we'll do is just go ahead and take 25 right here. That's machining nice right there. I'll take a measurement. I usually try to split the last two cuts equally. Equalize the tool pressure. All right, so we got 22 plus 5. Yep, so let's just take so let's take 27 thousandths. 10, 20, 5, 6, and 7. Always go like 5 thousandths under when it's going to be a thread form. You can see just how bad that rung my ears. Boy, I didn't have my earplugs in there, but you can see just what kind of havoc it wreaks when you're trying to get onto that hardened section right there. That was just on that face cut, but I can clean that up. This is not a real critical length. We just wanted about a 1/2 inch, and in case I forgot to tell you, whenever we go to set up our stainless steel ball to mill these, I'm just kind of replicating the original, but you know, I'm going with a larger ball. We're gonna drill down in here 3/4 of an inch, and I've already designed this in Fusion, and we can show you that later too. So I can, in Fusion, I can tell, because of the diameter of this, how deep or how long this journal can be without breaking through the bottom side. So the hole in the ball is going to be 3/4 of an inch deep once we mill the flat on it, and that 1/2 inch length there is plenty of material there to hold that ball on. Next up, we're going to do the undercut and the threading, and for that we're going to use our Walter MX22 tool. I love these things. You got 4 cutting edges. You can have full radius inserts, square inserts, threading inserts. I just love this tool. It works great. So this is a 3/32 wide grooving tool there, about 93 thousandths. And then our double depth, so that's what we're going to be taking. Double depth for a 20 pitch thread is 65 thousandths. So that's what we're going to take. I'm going to slow this down 1 speed and come in here. If you guys can see that. We're going to touch off on our diameter. There's our touch. I'm just going to zero this cross slide here, and then we're going to go in. See that chatter? That's because of the RPM there. So if it's chattering on you, slow it down. So we're going to go to medium range. We're going to go back to 380 RPM. And try to get in there quick. And it helps too if you move over a little bit and get off of the full radius. So we'll go back in there, 65, move it out just a little bit, just like that. It's okay to widen it a little bit. Doesn't have to be the same width of the tool. Give yourself a little bit of room for your threading tool to get in there. Let's see if we can back face this with just this grooving tool right there. I'm just hand feeding it back, and it's cleaning that up nicely. That looks good. That looks pretty good. Now we do need to chamfer it. We'll do that. We'll get that chamfer on there. And you know, the one thing that I didn't show you guys is checking the diameter that we finished on. We were looking for 495, and I don't know if you can see that, but we're on 495 thousandths, so that worked out pretty good. All right, so we'll take our grooving tool out. I got a chamfer tool up here. Uses a CNMG 432 insert. Use this to create a chamfer here on this side. And let's go ahead and break this corner as well. Just like that. And now we can go ahead and set up our threading tool and go ahead and thread it. And then I'll get you a nice shot of that. So we're going to grab our other MX22, which is this guy right here, with our threading insert. All right, we're ready to touch off. I think we'll go ahead and paint it blue. It's a little bit easier to see that in the videos, and then we'll go ahead and get our threading done. We're ready to thread. We've already got the machine set up so that it'll cut 20 threads per inch. Cross slide is set to 0, so we're going to use our compound to set our 0 there. We are going to be using compound end feed today. There's our touch off when we set at 0. All right, we're going to move it in a couple thousandths and go ahead and make a spring pass here. Back into our 0. All right, and then my #1 rule when you're threading, always have you a screw pitch gauge, like this guy right here, and 20 threads per inch, and we want to check that and verify that we are cutting our correct pitch. Because you don't want to go and cut it full depth and then realize that you've got it set one notch off on the lever and you're cutting the wrong pitch. So that looks good. That is lined up. You may not be able to see it that well. Let me move it back here. That's lined up on 20 threads per inch. All right, so we'll go ahead and carry on with our threading now. I'm doing this all by hand, manually disengaging. And we're going to be going in about 37 thousandths on the compound. Taking 5 thousandths per pass here. Now we're just kind of sneaking up on it, getting really close, and then we'll start checking it with our gauge. All right, let's go ahead and get our go gauge over here and check it and see if it'll start going on there. All right, we got our go gauge right here. All right, still tight, and I've cut it big purposely so we don't undershoot it. So we're going to go back in there and make a couple more passes. And I think now that we got it really close down to near our final thread form, we'll go ahead and put a little bit of our cutting oil on there and to help improve that finish. So we'll go ahead and just, oh, I'm sorry, that's the wrong one. That's my whey oil. It's the wrong oiler. This is the one we want right here with our dark cutting oil. Make a couple of passes here. That's looking a little bit nicer. We'll check our thread again. Still a little bit tight. So I left it about 5 thousandths small with the hopes that we could sneak up on it. That is the go there. So let's do that a couple more times. Oh, almost got it right there. We can clean that up with another towel. Go pitch. We want this one right here. A little bit tight, a little bit. I think it would help if we just take one more pass on that, take another thousandths, and then I'll hit the top of the thread with a fine file just to make sure that we're not rubbing on any burrs as well. So let's just take one more little pass on here. 0, and then 1 on the compound. Just like that. And I'm gonna go grab a file. Got a fine file right here, mill smooth. Just want to knock the burrs off. That's all you're really doing. All right, we got our go right there. Feels good. Feels just like it should. No go. And it doesn't go on there, it gets tight. If the no-go screws on there, that means you've taken it down below this pitch diameter, which is out of tolerance, and you've cut the thread too small. So if you can get it to fit between the go and the no-go, you're right in the range that you need to be, all right? All right, so I'm gonna give that thread a little bit of polish there. First thing I'm gonna do is just go ahead and go back in with our fine file, our mill smooth file, and just make sure that there's no sharp edges there or there. And yes, I touched it with my thumb. And then this is gonna go against a lot of the safety Nazis rules on what you do and what you don't do, but this is how I like to polish a thread. Use some Scotch-Brite here and just hold that up. That's why I said file it and make sure you don't have any sharp edges on there, so it's not gonna cut through this and cut your finger open. But we've got it doubled over, right? And just hold it up there and just give it a little polish. And what it does, it just softens that thread up, that sharp edge, softens it up a little bit, and it makes it so that it doesn't feel so sharp. So I did touch that face very lightly with the threading tool, so we're just gonna clean that up again. Not a critical dimension, let's just make it flat. All right, so that side is finished now. Like I said, we've got it polished nice and smooth. Easy on the fingertips, not gonna cut you in any way, so we'll go ahead and take it out of there. Let's see if you can see it a little bit better here. Nope, doesn't want to focus, does it? There we go. All right, so that looks pretty good. Let's just go ahead and replicate the same thing on this opposite end, all right? Still a little bit big. A couple more passes we need to make for our pitch gauge to go on there. See, it stops. One more pass. Let's make another pass on there. All right, here's our go. We just made our finished pass on there. And it's going on there nice. No movement on the thread whatsoever. And then here's our no-go gauge. And that one gets tight. So that's great. You don't want the no-go to go on there. So we're in the center of our range there. That thread's ready to go. Just need to do a little bit of polishing. So I've already got it filed. So grab our handy little Scotch-Brite pad and let's go ahead and kick it up into high gear. Go up to 620. Just kind of hold it with this and I use the bottom of my fingers there to kind of push it up in place. And just kind of break the sharpness off of the thread so that whenever you touch it, it's just got a nice soft feel there. You don't cut your little digits. Ready to go. Let's get it out of the lathe because turning and threading is completed. I wish we had the balls already bored and thread, but this is going to be the next phase of the project. But let's go ahead and come over here to the spindle and at least kind of stick it in here and get an idea of what it's going to look like. Close fit. I love that fit on that thing. There we are. All right, guys, we just finished turning and threading our new handle there. So what I want to do is I would like to go ahead and get the spindle installed back into the dynamic jaw and the hardtail. We've got the hardtail. Well, there's both of them. The gray one there, that's the one that we've been building. So I'd like to pull that dynamic jaw out and go ahead and get the new spindle installed in there. And on each side of the dynamic jaw, we're going to have a thrust bearing. So you're going to have a thrust bearing on this face right here, and then on the inside of the jaw you're going to have another thrust bearing inside here, and then there's a collar, and there's one more component that I forgot to grab, and that is the spring. So we'll have a spring here, and then this collar is going to slide on, apply some pressure against it, tighten it up, and that's really it. So we'll go ahead and get that in and get this guy finished up. I'm hoping to start on machining the balls for the end of the rod here really soon. So just want to go ahead and get this back in the vise. So let's knock that out now. We've already got it coated down with our CRC SP350, so it's got some nice rust inhibitor lubricant already on it. But the thread, I want to go ahead and put a little bit of oil. I've got some whey oil in this Eagle 66 right here. So let's go ahead and just Put a little bit on there, because once this is up inside the hardtail, this right here, then you can't access it. This is a solid box, unlike a lot of your older traditional vices that had a slot in the bottom where you could lubricate it. Once this is in there, you can't really lubricate it unless you pull it back out. So we're just going to go ahead and get some oil on this now, and it'll be there. This is just the same way lube that I use on all the machines. All right. Should be more than enough right there. There you can see some of the SP350, this white color, where it got a little bit thick. So that'll just stay on there and keep this area from flash rusting as it's inside the vise. All right, so we got to get this jaw out of here. I think I'm just going to manhandle it, just pull it out, and we'll set it over here and work on it. About like that there. Just trying to get it over here. We can set our camera right here so you guys can hopefully see the spindle going through here and getting put back together. All right, so there's the access hole. This is where you're going to see the spring and the shaft collar, and the other thrust bearing gets pushed up against this face right here. So I'm going to put these thrust bearings in this little throwaway paper bowl, and we'll put some way lube on them. So there's your thrust bearings right there. By the way, I bought these from McMaster Car. And we're just going to take our way lube there and just get some oil on them. All right, that should be good. And we're going to have to take one. I think I'm going to take this guy right here. We're going to have to get it installed in the end of the vise here. Let me move the camera so you can see. I think it's easier just to stand the spindle up here, and we'll just go ahead and slide one of these thrust bearings over the top so you have a washer on both sides of the bearing itself. There you go. All right. So now we need to stick it through here. And let me make sure you guys can see it, because this is where you've got to slide it through. We've got to get our other thrust bearing on. We've got to get the spring on and the collar, and then slide it all the way through and keeping all those parts right here. Okay, let's try this. Let's give this a shot. Thrust bearing, and we've got our spring. Uh-oh. Oh, I think we got a problem. I think our spring is too small. I did not check that. All right, back out we come. All right, so we got a hiccup. I did not think that spring was going to be that tight on there. I don't know. Let me see if we can thread. Well, no, that's gonna jam up on them threads. I don't want to do that. It's trying to, yeah, it's trying to rub that. Yeah, it's creating a burr. Don't want to do that. Okay. Change of plans. I'm going to have to find the proper spring there. I thought for sure there would have been enough clearance to go over this 1.25 inches. I didn't realize it was such a tight fit, so this is totally my fault. Never thought to check the diameter, the inside diameter of the spring. So this is not going to work. We're going to have to backtrack here. Well, that one kind of threw me off guard there, and I wanted to go ahead and get this spindle put back in the dynamic jaw and get this back in here and just have it ready to go for our next phase, which was going to be, well, we've got to machine the balls for the handle. That's the next thing that I'm going to work on, but we still have the nut that we have to modify as our last major project that we got to do for the hardtail. Let me grab it. It's over here. Yeah, that was my intentions of having them all together, and then we could take this guy and modify it. So just in case you didn't see the previous videos where we made the new Acme nut, I'm going to take the original hardtail nut here. We're going to part this threaded end off, and we'll part it so that we can machine both this nut and this piece here, a male female thread it together, use some Loctite, pin it, whatever we need to do, and then turn it down to this 2-inch diameter right there. So this is kind of the last puzzle for getting all of this stuff completed and everything back together. So I'm going to have to go in there and do some research. Hopefully McMaster is going to have some springs. This is kind of a you know, I don't know, it's just a specific spring that was made to go over this spindle here, but I upped the size a little bit and went to 1 1/4 inches. I'm trying to remember what it was before. I want to say it was around 30 millimeter. Let me see. We got some calipers over here we can use. I don't even remember what the original spindle was now. 30. I think it's 30 millimeters. It's actually measuring 30.4, and that was a trapezial thread. And so we went up 2 1/4 inches, which is a little bit larger. So about 32.7 millimeters is what that measured right there. And then so you got this spring, 31 millimeters. Little bit too small. Got to go see what I can find. See if we can find us the same spring that's got 1 1/4 inch inside diameter. It looks like it's about 1.5 inches long, and hopefully the same diameter of the wire there. 175 thousandths is the wire diameter. So anyway, I got a little bit more work to do, but we're going to go ahead and I'm just going to pause on this, locate a spring, get that coming. So the next video line, we'll go ahead and start working on the 2 balls that screw onto the end of the handle, and we'll get that done. This is going to be a fun CNC project for me to do. We're going to use our Miltronics to machine some soft jaws to hold a sphere, and then put the ball in there and go in there and do our machining. So we'll start on that one next. So I wanted to show you this back together today, but it wasn't in our cards. So anyway, I hope you enjoyed the other part of the video, doing our turning and threading. Tried to get some fun video to share with you of that, and we'll see you on the next project. All right.